Let's see the fifth question. So the fifth question over here is to pick any data set which includes numerical, non-numerical variable, perform EDA, and apply three classification algorithms, which is naive, SVM, and KNN. Let's see the demo part of this fifth. So I have imported the necessary libraries over here. So these are the necessary libraries which I felt, and this is what I imported. And the data which I have taken here is the IBM data set. So it consists of whether a particular customer churns or not. So by end of the day, we should be able to predict whether a particular customer will be churned or not, given on the basis of the categories. So this is where I'm reading as a pandas data frame, and I've displayed it. These are the 5 records on the top, and the shape is we have around 7,000 records and 21 columns. These are the types of each of the column, and I verified is there any null. So there is no null, and these are the object related columns over here. And I have seen that there is empty data present in the total charges column. So this is what it is, and I see there were around 11 records, and it came around 0.15%, which is very less than. So we can simply go and drop those records, or sometimes if it has good impact, we would be replacing it with a mean value. So here I followed deleting those records as it is very less percentage. So I replaced it with an npnan, and then I dropped those records, and I've converted them to float and made those columns as float. And these are the unique values present in each of the data related columns. So gender, senior citizen, so these are the data related, category related, qualitative related attributes, and this is respect to data. So I saw that there is no use of the customer ID, as there is no impact for the machine to learn this particular column. So I went ahead and dropped this column. So this is the existing visualization. As I said, it deals about the churn and non-churn, and it is around 26% of the data is churned, whereas 70% the data which consists 70% is not churned. So this is the correlation on the numerical data. I see that the monthly charges, total charges, and tenure are the correlation, but among them is with monthly charges is highly correlated, monthly charges and total charges. So we can go ahead and drop the total charges, as there is two columns are highly related, which doesn't make any sense for the model to learn these two columns. As it learns one column, it would be enough for the model to learn of that particular column, as they both are highly correlated to each other. And this is the just correlation across all the columns, and churn is the major factor which we would be looking at. And as I said, these particular columns are category columns, whereas the models would be expecting the data in the quantitative manner. So here what I did was I mapped it with S as 1 and the no as 0, as this column consists of S and no. So all this gender, partner, dependent is phone service, and paperless billing, for all these columns I've converted respectively to 0 and 1s. So it is same using the pandas get dummies. So I saw that multiple no phone services is always no when there is multiple lines no is selected. So I have removed this column, as it doesn't make any sense, as we are capturing the same data under the multiple lines attribute as no. So it is always true when it is no. So for all these columns I have dropped it, as it's capturing in its respective column called, if you take this device protection no internet services, if there is no internet service, if the user has internet service no, it's always device protection no is always true. So it doesn't make any impact, as this particular record is captured with this internet service. So after removing all these columns, it came to around 33. So these are the distinct columns which I had now. All, if you see, all zeros are ones, whereas before is yes and no. So here as well, I have standard normalized the data. Same with minimizing the min and dividing the max minus min to make sure that each column has given equal importance and it is range between 0 to 1. So here I have used RFE method. So what is the RFE method? Is recursive feature elimination method, which is similar to the backward selection. It identifies which columns are most important by eliminating one by one, by making a choice, selecting choice of 3 2 1 3 2 1. By this we'll know the most most effective factors. So from this I have taken the top 25 columns, and over here is the last column is the target and target column. So the test size over here is 70/30. So after selecting the data, this is how, after splitting the data, so churn is around 26% and 73%. So let's perform KNN. So basically, we have used in EDA to identify the most efficient columns and eliminated the inefficient, which are not that impactful, like phone services, no protection devices, no services, and total charges, and replace the empty data. So let's see the model phase. The first phase is KNN. So I've seen that when K is above from 15, it has good score. The on the y-axis is the score and the x-axis are the ranges. So here I have taken as K as 15 and I have initialized with n neighbors as 15, and I fitted it and predicted with an unseen data, and I got an KNN accuracy of 78%. So as it's a classification problem at hand, so I have used confusion matrix to verify the accuracy. So the same thing, I got 78% and precision recall, and this is the more detailed level. The same thing I did with the SVM. I've initialized, so I got this hyperparameters using a grid search over here. After performing this, I got this grid search, and here are the values. So it's the same thing. I fitted the values and I predicted it, and this is the confusion matrix which I got. It has 80%, and this is all detail level, precision recall, reference code, and support. And the naive is also the same. What is it? I have initialized the model and fitted the training and test data and predicted the unseen data, and the accuracy of this model is 73%. The same thing I did using the confusion matrix to get in more detail. So this is what it is, and 73% is the naive basis. Out of all, I see that SVM has much more has given me the good accuracy, which is 80%, whereas rest all others are around 73 and 74%. Yeah, this is all about the fifth question. Thanks.